Okay, let's do the circuit together just so you guys can replay if you have questions. So we'll start here. Prime of 3 pi over 2 given f of t is that integral. Okay, so you want to first find the integral and then plug in. So the derivative with respect to t of the integral from 5 to t of this function is, we're going to use part 1 that says that the derivative of the integral from a constant to a variable of a function is the function, but you plug that in, that variable that you have there. Okay, it makes sense. The derivative of the integral, those are going to cancel out, but you have to make sure you use the correct variables. Okay, so then this is equal to, we're going to just plug this in, 2t over pi e to the cosine t. The dx, that goes away. Once you take the integral, that goes away, so don't worry about that. And you don't have to do a plus c because the derivative canceled with the integral. Alright, so that's f prime of t. So plug in 3 pi over 2. And this is 2 pi times 3 pi over 2. E to the cosine of 3 pi over 2. And then let's simplify that. And we get 3 e to the cosine of 3 pi over 2 in the unit circle. 3 pi over 2 is down here. The cosine is 0. So the answer is just 3. Okay. Okay, that takes us to our next cell over here. And now we're going to use FTC for this one, same thing. You want to find the derivative of this integral, negative pi over 4. So this is also part 1. However, this is what we're going to use the format where you take the derivative of the integral from 0 to some other function here. G of t, h of t. Okay, I'll use g of t. I think that's what we have in the notes. And then you have the function with respect to a different variable, dx. Okay, so same thing. You're going to plug in what's up here. Okay, but because you have a function, you have to multiply times chain rule. Times of g. Okay, this is what's important. This is what I'm worried about. So same thing here. We're going to plug in what's up there. And we're going to multiply times the tangent, which is secant squared. Okay. Then we can plug in negative pi over 4, but you can also use the rule that says that sine squared t plus cosine t equals 1. And if you divide everything by cosine, you get that tangent squared t plus 1 equals secant squared. So these actually end up canceling, so your answer is just 2. Okay. Alright, so that brings us down to this cell over here. The next questions are about h of x, the graph that's up there in the handout. Evaluate h of 1. Okay, so the graph given is that h of t is the integral, or the area underneath the curve from 1 to t of the piecewise function below. So if I want h of 1, I want the integral of 1 of this function. Well, 1 to 1, that's just 0. Okay? So that's what I'm going to use. I'm going to go ahead and put this in the cell below, just so I can send you guys the key and it's all there. Okay. Oh. Alright, let's, so my answer is 0 to this over here. I should number them. This is number 1, and then we did number 2. And that was number 3, and now this one's number 4. Evaluate h prime of 3. Well, let's find h first. So h of t is here. So if I want the derivative with respect to t of that function there, the integral from 1 to t of f of x, well, that's FTC part 1. Okay, the derivative and the integral, have to plug in the variable. That means that h prime of t, the derivative of that of h, is equal to just the function there. So what is h prime of 3? That's f of 3. And if you look at the picture, what is f of 3? What's the y value there of f? F of 3 is negative 2. Okay, so that brings us to h double prime of 1. Oh, okay, so I'm going to just borrow h, well, actually h prime, okay, so h prime of t equals f. H double prime of t is f prime of t, that's the slope. And what's the slope at 1? The slope at 1, if we look at the picture, is negative 1. Okay, I should have numbered these. This is 5. Okay, so that brings me to 6 of. What is h of 2? That is, what is the integral from 1 to negative 2 of f of x dx? All right, notice how from 1 to negative 2. Usually we go from a value where a is less than b. But what happens if a is greater than b? Well, we can flip them. Okay? So we can use the property that says that this is the same as the integral from negative 2 to 1. You can flip them. I'll leave out in front. So now you can go from negative 2 to 1. That makes more sense. You're going from 1. You're going to take this area and make it negative. Why is that so? Because if you're going to negative 2, you're going backwards. So the area that was positive is now going to be negative. So one more time. What is h of 2? That's the integral from from 1 to negative 2 according to what we have here. But we're going backwards. It doesn't make sense. We always go from negative 2 to 1. Then backwards here. So we're going to just take that area and make it negative. So this is the same thing as negative 2 to 1 of f of x dx. Okay, so what's my area here? This is 2 times 1. This is 2 plus a half. This is 2 1/2 or 5 halves. So now if I'm going to, because I have this negative here, I'm going to make this negative. So this is equal to negative 5 halves. All right, so that's my answer. My 7, so this should complete my circuit. My answer should be 2/3. Okay, so given w is equal to the integral from 2 to t of that function, find w double prime. All right, so the first derivative, simple. Replace the variable. Okay, I'm taking the derivative with respect to t. These cancel, you plug that in. Okay, second derivative. The derivative is 1 over whatever value you have there. Second derivative, plug in 5 halves, is 1 over 5 halves minus 1, which is 1 over 3 halves, which is equal to 2/3. That is it. That completes our circuit.